Hello everyone, welcome to Tongal online classes. In this session we will discuss the new concept. Today's concept is optical instruments. In this session we will see how structure of human eye looks like and what are vision defects and simple microscope and how simple microscope can do works. This phenomena we will see in detail. Now let us go. Today's concept is concerned to optical instruments. The devices which works on the principle of refraction, reflection, total internal reflection, those we are calling optical instruments. Generally, the human eye looks like an optical instrument. The human eye made up of the convex lens. Let us see initially simple structure of human eye and what are vision defects of the human eye. That phenomena I will see in detail. Initially, we know that the natural optical instrument is nothing but human eye. For our human body, the eye looks like an optical instrument. The eye, it is made up of double convex lens. See here, simply we will see how structure of eye looks like and what are vision defects. Look at me. Now can call this is nothing but simple structure of human eye. This you can call simple structure of the human eye. See here. And the human eye made up of double convex lens. See here. This human eye made up of double convex lens. This is simple structure of human eye. The human eye mainly made up of three parts. One part we are calling cornea, and second one we are calling eyeball, and third one is nothing but retina. See here. This part I can call cornea, the bulging part. This is what I can call cornea. And second part, eyeball. And this part I can call retina. This is simple structure of human eye. This part I can call retina. See here, through the cornea, the ray of light comes and incident on the eyeball, such that on the eyeball the ray of light can refracted. As a result, image of the object can appear on the retina. If exactly image can appear on the retina, then the human eye is nothing but normal human eye. As concerned to human eye, mainly you are defining so many physical quantities and basic terms required the further study of vision defects that we'll see. Initially, the first term concerned to human eye is nothing but augmentation. This term we'll see. Look at me. What we know that when the ray of light incident on the cornea and get refracted through eyeball, as a result, the image of the object can appear on the retina. How it is looks like? Shall I take? Now from this, let us take the ray of light incident on the cornea and refract through eyeball. As a result, image can appear on the retina. Shall I take one more ray of light like this? This ray of light incident on the eye lens. As a result, the image can appear on the retina. See here how it is. From this object, let us consider this is ray of light, that is passes through cornea, and after refraction through eyeball, this I can call eyeball, or simply we can call eye lens. It is double convex lens. Through double convex lens, if the ray of light incident and get refracted, so that the image exactly appeared on the retina, then I can define augmentation. Augmentation is the eyeball changes its focal length in such a way that the image of the object can appear at any point from the eye. That we are calling augmentation. How to say? The eyeball changes its focal length in such a way that the image of the object at any point from the eye can appear on the retina. That we are calling augmentation. Simply this augmentation, it is lying from 25 to infinity. 25 centimeter to infinity point, augmentation. If the case object is very far, then this eyeball changes its focal length, increases its focal length. Similarly, if the object is very near, then this eye lens or eyeball decreases its focal length. Due to that, the image of the object can appear at any point from the eye, that is appeared on the retina, that we are calling augmentation point. Then See here. Then after that, one more point we are defining, that is near point. Near point. Or this we are calling least distance of distinct vision. Least distance of distinct vision. See here, it is the point from the eye in which the image of the object can appear on the retina, or the near point from the human eye in which the image of the object can appear on the retina. That point we are calling near point. See here, near point means the around from 25 centimeter from the human eye. From 25 centimeter on the human eye, the image of the object can appear on the retina. That point we are calling near point. How to say? The nearest point from the human eye in which the image of the object can appear on the retina, that we are calling near point, and the near point is lying of the order of 25 centimeter. This point, this near point, how to represent? This near point can be represented by what value? Capital D. I mean, the nearest distance from the human eye in which the image of the object can appear on the retina. On the retina, that we are calling near point. Then, after that, one more point we are defining, that we are defining far point. Far point. Far point. Far point means the larger distance from the human eye in which the image of the object can appear on the retina, that we are calling far point. How it is? If the object is very far, then this eye lens increases its focal length, so that image of the object can appear on the retina. So that point we are calling far point. This far point nearly it is lying up to at infinity point. I mean, object is appeared at infinity point. The eyeball changes its focal length such that the image can appear on the retina. That we are calling far point. See, the near point is about 25 centimeter and far point is about what? Infinity point. But we know that wherever the ray of light incident from the object and the ray of light meeting on the retina, then exactly the image of the object can appear on the retina. Image of the object can appear on the retina. Then that eye is said to be normal eye. That eye is said to be normal eye. I mean, the image exactly appeared on the retina. Image exactly appeared on the retina, then that human eye is said to be normal eye. I mean, the eye does not any defects. Actually, due to some defects, either due to changing in focal length of the eyeball or due to elder region, due to so many regions, the human eye has so many defects. Those defects we are calling vision defects. Then let us see what are vision defects and what are types of vision defects, how they can be corrected, and what are the reasons due to that those defect can occur. That we'll see now. Next concept is vision defects. Vision defects. Vision defects. See here. There are four types of vision defects are there. One we are calling myopia, hypermetrophia, presbyopia and astigmatism. See here. How it is? Four types of vision defects are there. One we are calling what? Myopia. Second one, hypermetrophia. Hypermetropia. And second one is what? Third one is what? Presbyopia. And last one is astigmatism. Four types of vision defects are exist. Vision defects mean the defect of, the image of the object does not appear on the retina. That eye is said to be vision defect eye. That is due to so many reasons. So I classified vision defects into four types. One is what? Myopia, hypermetrophia, presbyopia and astigmatism. Now let us see one by one vision defects and what are the reasons how they can be corrected. That we'll see. See here. Now shall I go? Initially I will move for myopia. Let us discuss the myopia in detail. Look at me. Shall I see here? First one is myopia. First defect we are calling myopia. Myopia. Myopia means the person which able to see near objects but unable to see far objects clearly. That defect we are calling myopia. How it is? The person unable to see far object clearly but he can see the near object clearly. That defect we are calling myopia. How to see? The person unable to see, distance object, unable to see distance object clearly is known as myopia. Is known as myopia. Actually, this myopia is due to decrease in focal length. Decrease in focal length of the eyeball due to increase in its size. Due to increase in size of the eyeball, the focal length is decreased. As a result, the image of the object not appear on the retina. Instead, the image of the object can appear in front of the retina. See here, we know that how the myopia can occur, and for myopic person how the image can appear, that we'll see. Look at me. What we know? Actually, this is nothing but structure of human eye. Again, I am drawing very simple structure of the human eye. Right or wrong? So this part I can call cornea, and what you can see? So this is the eye lens. This I can call eye lens. Right or wrong? This is the eye lens. We know that the ray of light incident where the image can appear on the retina, then that eye should be normal human eye. But in case of myopic person, due to decrease in focal length and due to increase in size of the eyeball, how the image can appear? Look at me. See here, this is nothing but object. From the object consider the ray of light incident, and after refraction where the ray of light can meet. Here. Let us take the one more ray of light incident from this object, get incident on the lens. After refraction where the ray of light can meet, at this point ray of light can meet. Actually, where the ray of light can meet, ray of light must meet on the retina. Then only the person is said to be normal human eye. But here, where the image can appear, the image exactly appeared in front of the retina. Due to what? Due to decrease in focal length, due to increase in size of the eyeball. So that this defect, what you are calling myopia. Then how this myopia can be converted? How the myopia can be corrected? Look at me. Where the ray of light meeting in front of the retina, and then I want to divert this ray of light. The ray of light. Actually, what causes it is occurred? It is occurs due to what? Increase in focal length. Or decrease in size of eyeball. So due to that reason, this myopic person can occur. Right. How this correct? The ray of light meeting in front of the retina. I want to divert the ray of light. To divert the ray of light, what we have to use? In front of the eye, we have to use concave lens. So that the myopic person, myopic defect can be corrected by concave lens. See here, how it is corrected? Now this myopia corrected by concave lens. Corrected by concave lens. How it is corrected? Of suitable focal length, we will see. Suitable mean, again I can take this is structure of the human eye, I can say. Normal structure of the human eye. This part I can call cornea. This I can call eye lens. Right or wrong? Now in front of this eye, what to use? We have to use concave lens. Right or wrong? When concave lens is used, then this is the object. This is the object. From this object, ray of light incident and get diverge. Diverge means it comes like this. Again, ray of light incident, get diverge. Ray of light can incident like this. Again, after refraction, where the image can occur, image can occur exactly on the retina. Then the myopic vision defect, it is corrected by concave lens. So this is concerned to myopia. Later we will see the one more vision defect that we are calling hypermetrophiya. Hypermetrophiya, that we will see. Next one is hypermetrophiya. 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 Hypermetrophiya means the person unable to see near object, but he can see the distance object clearly. That vision defect we are calling hypermetrophiya. How to define? The person unable to see. The person unable to see. Unable to see. Unable to see near objects, unable to see near objects, clearly is known as hypermetrophiya. Hypermetrophiya. How this hypermetrophy can occur? The hypermetrophiya is due to increase in focal length. Actually, not increase in focal length. Actually, this is what? Due to decrease in focal length. Sorry. This is what? Due to decrease in focal length, not increase in focal length. Hypermetrophiya is due to causes increase in focal length. Because due to increase in focal length or due to decrease in size of the eyeball, the image not appeared on the retina. Instead, the image is appeared behind the retina. How it is? See here. What causes it is occurred? It occurred due to what? Increase in focal length. Increase in focal length. So this defect can occur. Increase in focal length. Then for a hypermetrophic person, how it is there? How it is exist? Look at me. Now I can take again the structure of the human eye. Simple structure you can take. Structure of the human eye. This we can call eyeball. Are you following? Let us take the ray of light. The ray of light incident from the object. This ray of light, how it is meeting? It is meeting like this. Again one more ray of light. Get incident, and where the image can occur? Image exactly appeared behind the retina, not on the retina. So that this person defect, what you are calling hypermetrophy. Due to this reason, the person unable to see near object, but he can see distance object clearly. That we are calling hypermetrophy. Then this hypermetropia, actually it is due to decrease in size of the eyeball, so that focal length increase and power of lens can be decreased. Due to decrease in power of lens, the ray of light can meeting behind the retina. Then I want to decrease just the convergent ray of light. Actually the ray of light converges away from the eye, and then I want to exactly convert the ray of light on the retina. To convert the ray of light, what lens we have to use? To convert the ray of light, we have to use the convex lens. So that hypermetrophiya, it is corrected by convex lens. See here, how it is in front of the eye. Again I will take, see here, for this only I can take, look at me, simply I can remove this. This is nothing but structure of the human eye. Very simple we have to use. Look at me, structure of the human eye. Then let us take any one object available here, ray of light incident. Here what we are using? We are using convex lens. See here, for my convenience I will take one second diagram. Look at me, how it is corrected? Hypermetrophiya can be corrected by convex lens. Corrected by convex lens of suitable focal length. Corrected by convex lens. See here, again you can take, this is structure of the human eye. right thing. This part I can call cornea, right? This is the eyeball, right or wrong? Structure of human eye like this. What we have to use? In front of the eye, if we use the convex lens of suitable focal length, this is suitable focal length. Now, consider the ray of light incident from the lens and it get converge. Ray of light can converge. Similarly, one more ray of light incident on the lens and again this ray of light can converge like this. After again passing through this eyeball, how the ray of light can comes? The ray of light can converge at this point. So that where the image can occur, exactly image can appear on the retina. So, hypermetrophia or the person unable to see near object, that is corrected by convex lens. Then later on we will see what is astigmatism and presbyopia, that we will see. Look at. After this, now we will see directly astigmatism. Astigmatism. Look at. Shall I take this? After this, now we have to use astigmatism. Astigmatism. How it is? The vision defect in which the person unable to see horizontal line and vertical line at the same time clearly, that vision defect we are calling astigmatism. For astigmatism person, if horizontal lines appear, then vertical line should not be appear. Or if vertical line appear, horizontal line should not be appear. That vision defect we are calling astigmatism. How it is? See here. Now can take this is nothing but structure of human eye. Again we will take. This is human eye, right? Like this. This part I can call retina, right or wrong? Now actually in front of the eye, let us consider any one object appears such that this contains so many horizontal lines and vertical lines. Vertical lines. In this case actually what happens? The ray of light actually meeting on retina, but for the person horizontal line can appear but vertical line should not be appeared. How this is? Look at me. Now again this is the ray of light incident on the lens and get refract and meet on the retina. Similarly the one more ray of light incident from this object again can meeting on the retina. So in this case what happens? In this case the image of the object can appear as blurred like this. It can appear. This image should not appear like this. It may appear like this appear. I mean here the horizontal line and vertical line should not be appeared clearly. That vision defect we are calling what? Astigmatism. This astigmatism how to correct? The astigmatism it can be corrected by cylindrical lens. How it is corrected? It is corrected by cylindrical lens. Look at me. How it is? If the case in front of the eye, if we use the cylindrical lens, then the ray of light incident and passing through lens, passing through eyeball, as a result again image can appear on the retina, so that image of that object can appear very clearly. Then astigmatism how to correct? The astigmatism can be corrected by what lens? It is corrected by cylindrical lens. It is corrected by cylindrical lens. Corrected by cylindrical lens. Then after this, the one more vision defect we are studying, that we are calling presbyopia. 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 See here, it is a vision defect. It is vision defect. It is occur due to the person which unable to see distance object and far object clearly. That vision defect we are calling presbyopia. How it is? The person which unable to see near objects along with the distance object clearly. That defect we are calling presbyopia. The presbyopia generally it is occurred due to olden days. When age of the person goes on, gradually the eyeball loses its flexibility. Due to that reason, the person unable to see near object along with the distance object clearly, so that the image cannot appear at a near point or at a distance point. That vision defect we are calling what? Presbyopia. This presbyopia, how it is corrected? The presbyopia required both convex lens and concave lens, so that this presbyopia can be corrected by bifocal lens. Bifocal lens, I mean combination of convex lens and concave lens, using that the presbyopia may be corrected. So these are vision defects. One concern to myopia, hypermetrophia, presbyopia and astigmatism. After the vision defect, let us know what is simple microscope and compound microscope. That we will study in detail. Now, after this, shall I move? After this, let us take what is simple microscope and how the image can appear. That we will see in detail. See here. After this, now we will see what is mean by simple microscope. Simple microscope. What is simple microscope? The optical instrument which produces the sharp image of smaller object. What is simple microscope? It is an optical instrument. It works on the principle of refraction, which produces the sharp image of smaller object. That optical instrument we are calling simple microscope. Then simple microscope only consists of one convex lens. Double convex lens is exist. Shall I define here what is simple microscope? The optical instrument or the device which produces sharp image of smaller objects, that we are calling simple microscope. See here, simple microscope, it consists only one convex lens, so that the sharp image can appear by taking two cases. See here, how simple structure, how the ray diagram of simple microscope it is appeared. Look at me. This is nothing but simple structure of simple microscope. This is simple structure. This is double convex lens of suitable focal length. Then the straight line passing through optical center, that we are calling principal axis. What I can call this is nothing but optical center. Radar on this. Now, the image can appear in two cases. One is if the object is placed in between pole and principal focus, so that virtual image can appear at a near point. Near point means the minimum distance from the human eye, so that the object image can seen very clearly, that we are calling near point. So near point means about 25 centimeter. Look at me. Now two cases we will see. Image appeared at a near point and image appeared at infinity point. Both cases we will see. Final image appeared at a near point, that we will see case. See here. First case we will see the final image appeared at near point. Right. Now see here. Now consider the object is placed in between pole and principal focus. Look at me. See here, I can take this is nothing but principal focus. Say this is nothing but f value. Now object is placed in between center of curvature, I mean the center of point B and principal focus. So this O what you are calling optical center, F is nothing but what? Principal focus. Right. Now when object is placed in between pole and center of curvature, always the image is appeared as a virtual and sharp image can be appeared. See here how it is. Now consider the ray of light that is incident on the lens, and after refraction how the ray of light can passes. The ray of light can passes like this in this direction. Right. Now, let us take one more ray of light that is passing through optical center such that the ray of light never deviated. Already we know. See here how it is. The ray of light which is passing through optical center, this ray of light never deviated. And how to take the image, that is important. See here. If the refracted ray produced in backward side, so that image can appear at some other point. Look at me. How it is. Now, if the case, see here, shall I extend this? If the case this refracted ray, how it is? This refracted ray produced in backward and this refracted ray produced in backward. So that where the image can appear, exactly image can appear at A dash, so that if we join this, look at me, how to join this? If I take like this, where the image can appear at A dash, then if we join this indicates what? A dash, B dash. This A dash, B dash represent what? Sharp image. I mean, object is very smaller, image is appeared very bigger. Right. What you are calling? This is nothing but size of the object O, and this what you are calling size of the image I. Then what are magnification? What are angular magnification? That we will see for the simple microscope. I mean, the image appeared at a near point. Near point means where the image can appear. Exactly the image can appear at this point, that is represented by V, and where the object is available, this is the object is available, that is represented by what value? U. So that how to take? So from this object OB is equal to what value? OB is equal to minus U, and V is equal to D. Image is appeared at near point, that is represented by what value? Minus V. So which is equal to what value? This is equal to OB dash. Write on this. Now, how to obtain magnification of simple microscope in this case? We know lens formula. See here, what is lens formula? Lens formula can represent by 1 divided by F is equal to 1 divided by V minus 1 divided by U. You know this formula, right? Then from this one, what you can take? So from this formula, just divide by V on both sides. What will get? V divided by F is equal to V divided by V minus V divided by U, or else what you can take? V divided by F is equal to 1 minus M, because ratio of size of image to size of object we are calling magnification, or else what you can take? Minus M is equal to V divided by F minus 1. Now just multiply this minus on both sides. See here, M is equal to what value? M is equal to minus V divided by F plus what value? 1. Right, or else. Again, how to take this magnification? This magnification M is equal to 1 minus V divided by F. But what is V? V is equal to minus V. D is equal to minus V here, according to sign convention. V is equal to D, and D is equal to what value? Shall I take this value? V is equal to what value? Minus D I can take. Right. Take V is equal to minus D, then from this what you can take? M is equal to what value? 1 plus D divided by F. This is magnification of simple microscope when image is appeared at near point. But we can achieve this relation in terms of angular magnification. Angular magnification I will define later. Before that, see here. Now actually this is the ray of light coming. This ray of light I can produce in backward side like this, from this. And from this point I can extend one more point. Look at me, this is one more point I can take. Are you following? Then this I can call angle made by the object that are represented by theta naught. Which one is the triangle here? So shall I take this is one triangle? I can take this is one triangle. Right around this. Then this I can call the angular magnification which is appeared by image, that is represented by theta I. Represented by theta I. We know angular magnification. Angular magnification is a ratio of angle made by the image to angle made by the object. Here two triangles are here. Which is the triangle? See here, OAB looks like one triangle. In OAB, theta is nothing but angle. One more triangle looks like OIB dash, one more triangle. In this triangle, theta naught is nothing but angle made by the object. Right around this. Then I can define angular magnification. In what way? Angular magnification, it is defined as angle made by the image to angle made by the object. angle made by the image to angle made by the object, that we are calling angular magnification. From this formula you can achieve this formula again. How it is? We know that whatever angle of incident, whatever angle of refraction, those are assumed to be very, very smaller. Those are assumed to be very, very smaller. Sin theta or tan theta is very smaller, then sin theta or tan theta nearly equal to theta. So look at me. In this triangle I will take, in the triangle OAB triangle. See here. In triangle what? In triangle OAB. Which triangle? Theta is the triangle. Shall I take theta I? I mean tan theta I. Tan of theta I is equal to what? AB divided by OB. This is what? AB divided by OB. Right around this. AB divided by OB. Then theta very, very smaller. Tan theta nearly equal to theta. Then from this theta I is equal to how much? Theta I is equal to AB divided by OB. Again, one more triangle. OIB dash. OIB dash. See here. Triangle what? Triangle OIB dash is the one triangle. In this triangle again we will take tan theta because the theta naught looks like theta naught. Then how it is? Theta naught is equal to how much? Theta naught is equal to, I can define IB dash divided by OB dash. But look at me. In this figure, this IB dash is nearly equal to AB. So that IB dash again replaced by what value? AB. Theta naught is equal to what value? AB divided by OB dash. Now can define angular magnification. That is what value? Theta naught divided by, actually it is tan theta. Theta is very, very smaller. Tan theta nearly equal to theta. So that. Again from this magnification by taking this formula, M is equal to theta I. Where is theta I? AB divided by OB. AB divided by OB into OB dash whole divided by what value? AB. This AB get cancelled. What is linear magnification then? Linear magnification is equal to OB dash whole divided by what value? OB. OB dash. What is OB dash? That is minus V. OB is equal to U minus U. Then from this what is linear magnification? That is V divided by U. V divided by U. But V is equal to again D value. V is equal to D. Then look at me. This formula can write. Magnification M is equal to what value? D divided by U, because V is equal to D. But taking this again we can achieve. How it is again? But taking lens formula, shall I take? Again take this lens formula. 1 divided by F is equal to what value? 1 divided by V minus 1 divided by U. Right around this. Again multiply V on both sides. Like this, multiply V on both sides. What you are getting again? This value. This value you are getting, multiply V on both sides, mean directly shall I get? If you multiply V on both sides again by this, what will get? Again we will get this formula. So that by taking this magnification, or shall I solve here only? No matter. Look at here. 1 divided by F is equal to 1 divided by V minus 1 divided by U. Multiply V on both sides. V divided by F is equal to 1 minus V divided by U. Right around this. But V is equal to D. V is equal to D. Then from this, V divided by F is equal to what value? V divided by F minus 1 is equal to minus M. Right? V by U or D by V, no matter. Or else M is equal to what value? 1 plus D divided by F. Linear magnification. Either we are getting by this formula or we are getting by this formula. This is what? Final image appeared on the retina if the case the object is placed between poli and principal focus. But if the object is placed exactly on principal focus, then image is appeared at infinity. How image appeared at infinity, and for that case how to take, that we'll see now. Look at. Now for simple microscope, wherever object is placed between poli and principal focus, then you can take magnification by what value? M is equal to 1 plus D divided by F. Now same simple microscope I will take, but in this case image is appeared at infinity when object is placed at exactly principal focus. Look at me. See here how to take. Now second case what will take? Image appeared at infinity. for simple microscope. Shall I take here? For this one, image appear at infinity. Look at me. How to take, that is important. See here what we know. Again it is convex lens. Simple microscope consists of a simple convex lens. This we can call principal focus. Right or wrong? This second call optical center O. Now exactly object is appeared at a principal focus. Let us consider this is object AB. This object AB exactly appeared at principal focus. When object appeared at principal focus, let us consider this is ray applied incident, and after incident ray applied refracted passing through principal focus. This is principal focus. Now one more ray applied that is passing through optical center such that never deviated. This is point. But if refracted ray it goes in backward side, where they can meet? Look at me. If the refracted ray they can produce like this, or this refracted ray produced come backward, they can meet at an infinity point. They can meet at a infinity point. So that where the image can appear, exactly image can appear at infinity for our convenience. How to take? Now again this is nothing but refracted ray. So incident ray goes like this. From this incident ray you could take like this. Then this I can take image. For my convenience I will take. So this point I can call A dash, this point I can call B dash, because A dash B dash is nearly equal to what value AB. Then where the image can appear exactly, for my convenience I will take image can appear at D. D is equal to V I will take in this case. Then what about this O India, that is U. U is equal to what value? Focal length. Because distance between pole and object, distance between pole and principal focus, both are equal. Now we know lens formula again. How it is? 1 divided by F is equal to 1 divided by V minus 1 divided by U. Around this. Now multiply D on both sides. V on both sides. Where the image exactly appeared? Exactly the image can appear at infinity. For my convenience I will take initially. V is equal to infinity. Then 1 by infinity is 0. Then what is remaining? 1 divided by F is equal to 1 minus of 1 divided by U. Right around this. Right thing? Now multiply D on both sides. Multiply D on or V on both sides. What will take? V divided by F is equal to what value? Minus V divided by U. But U is equal to V is equal to what value again? Minus D. V is equal to minus D. Then I can take like this also, or you can call this is magnification. See here how to take this value. V mean I can take V is equal to what value? V is equal to minus D I can take. Right around this, or V is equal to simply I can take minus D. Then this becomes what value? D divided by F is equal to what value? So this is what value? And D divided by what value? U. This D divided by U is equal to what value? That is nothing but linear magnification. So that how to take this value? M is equal to what value? D divided by F. This is linear magnification is what? In case of image is appeared at infinity. This is concerned to one simple optical instrument that we are calling simple microscope, where the image can appear at infinity. Image can appear at infinity, for that magnification can take like this. And image appeared at near point, the magnification can be taken M is equal to 1 plus D divided by F value. You can take angular magnification also, no matter how it is. So here from this you can take again, this is one ray. So this I can take theta I, and this what we are calling that theta I. So this we are calling theta naught, this we are calling theta I. But taking angular magnification you can take this relation. What it is? M is equal to D divided by F value. One more optical instrument, that is compound microscope. How it is works, that we will see in the next session. Thank you.